write down the givens. Those are some free points right there. So I've got E is between R and A, right there. That's given. I've got a second given. Let's write that one down. V is between E and A. And then in terms of getting points, what I have to prove is always at the end. So RA equals RE plus EV plus VA. So let's see what this is trying to tell us. First given, E is between R and A. E is between R and A, so RA is the entire length of the entire long segment, and E is somewhere between it. What I know from that is RE, this short segment, this part, plus this whole part, EA, will give me that segment. So that's going to be my next statement that I write down, is I know that RE plus EA equals RA. So that's what that first statement's telling me. So RA equals RE plus EA. And that's because the segment addition postulate allows me to do that. Part plus part equals whole. Those are two segments being added together to get the whole segment. That segment addition postulate. Let me write down given for that second one. So far I know where I'm headed, RA, RA, RE, RE, and I got EA, and this is something different here. Well, this next statement, next given, is going to give me my fourth step. V is between E and A, so there's my EA. That's my EA. So looking here, EA is this whole segment, and that is this part plus that part. So EV plus VA equals the whole segment EA. So that's what I'm going to write. EA is EV plus VA, because the segment addition postulate allows me to do that. Add segments together. Two parts equals a whole. And then what I notice is RA is the same as RA, RE is the same as RE, but this EA turned into something else here. But if I look, EA is all of this. So if all of this gets plugged in there, I end up with this statement. So since I plugged that in, our mathematical term for that is substitution. So the substitution property allows me to plug that in. And I have now proven number one. All right. Number two. I'm going to write down the given. RV, the line RV is congruent to the line EA. That's given to me. And just so I make sure I get my points, I'm going to write what I need to prove down at the very bottom. RE is congruent to VA. It's nice to know where we're headed. So let's see. I'm not really sure where to go with this yet. So what I'm going to guess is that I'm going to have to add up some segments like I did in number one. And in order to add up segments where they're equal to something, I need to switch to equals. And right now I'm in congruence. So I need to switch from congruence to equals. So I've got RV, the length RV is equal to the length EA. And the definition of congruence is why I'm allowed to switch between congruence and equals. So we use this one a lot. Next, RV. So what's RV over here? So RV is this length, and that's RE plus EV. So RV equals RE plus EV, right? And segment addition postulate allows me to do that. I have another side to this, another half. I've got EV, or EA. I got EA. So what's EA look like on here? EA is this whole segment, and that's EV plus VA. So EA equals EV plus VA. And again, segment addition postulate allows me to do that. So I started from the line segments being congruent to saying that they're equal to each other. I figured out one of them and what it's equal to in terms of segment addition postulate. Then I did the second one, EA. So now that I know these bigger parts, I'm going to plug them in. And so RV equals RE plus EV. And that equals EA. And EA down here is EV plus VA. So I took these and I substituted them into the top one. That's substitution property. Then if I look at this and try and figure out what I'm doing, RE plus EV equals EV plus VA, I should notice that I've got two EVs in there. And if I look at the bottom, the RE matches up, the VA matches up, so I need these to disappear. So if I subtracted EV from the left and subtracted from the right, those would cancel out, and I'd be left with RE equals VA. I subtracted, so that's subtraction property. Last step. How did I go from 6 to 7? I went from equals to congruence. So anytime I go from equals to congruence, just like I did above, that's definition of congruence. This one is definition of congruence. Proved it. Last proof. I'm going to start with number 3. Start with what I'm given. E is the midpoint of RV. Let me write that. E is the midpoint of RV. That's given to me. Check. Use that one. Let me write the second one down just to make sure I get my points. So RE is congruent to EA. That's given to me. If you recall, I need to use both of my givens. So if we're stuck right here, we're going to look at our first given and see what that tells us. E is the midpoint of RV. So I look over here, E is the midpoint of RV. Well, I should know that if that's a midpoint, these two parts are congruent. Because that's the definition of a midpoint. It's in the middle. So those are the same. So I can write RE is congruent to EV. RE is congruent to EV. And I just said it. I know that because I know the definition of a midpoint. So number 1 led to number 3. All right. Now I've got RE is congruent to EA. I've got RE is congruent to EV. I should recognize I got RE in both of those. So if EA leads to RE and RE leads to EV, I can get rid of the middleman here, and I've got EA is congruent to EV. So EA is congruent to EV. Anytime I go from one thing to a second thing to the third thing, and then conclude that I can go from the first to the third, that is the transitive property that allows me to do that. Transitive property. I didn't write down where I'm headed, so let me do that real quick. Prove EV equals EA. And now that I write that, I recognize that this looks similar, but it's backwards. I've got EA, EV, EV, EA, so I need to flip those around. So if I flip those around, I have a property that allows me to do that. Those are flipped around, and that's the symmetric property that allows me to do that. So if I flip two around, that's the symmetric property every single time. And then to finish it off, how do I go from here to here? They look the same, EV, EA. I went from congruence to equals, and that is the definition of congruence. Done. Go get it.